the entire avionics systems of most commercial aircraft built in the 1980s.
4 starts, sir. Let's go back. I can do that. Window is open on the left. Octopals, master. Check left. Check right. En route. Check. 164.5, I believe. Release fuel is 164.5. I see 164.5 set. 164.5 and set.
Propelled by 200,000 pounds of thrust, more than was used to send the first men into space, the Boeing 777 blasts into the sky, headed over the Atlantic. With 250 airships flying for 23 airlines and 180 on order, the 777 still qualifies as a brand new plane. But a brand new plane takes more than a decade to build. Boeing began work on this most modern airship in 1988. The 777 was an aircraft born out of necessity. In 1988, several airlines approached Boeing to build an airship which could economically take 300 passengers on short hops as well as intercontinental trips. Boeing's 200-passenger 767, introduced in 1981, has a range of 7,000 miles, while its 500-passenger 747, which debuted in 1968, has a range of 8,400. But the airlines needed an aircraft in the middle, a plane that could carry 300 passengers for either short or long distances, and they needed this plane to be fuel efficient. Boeing realized it needed to build a wholly new aircraft. To do this, Boeing's facility in Everett, Washington had to be dramatically expanded to provide for 2 777 production lines. 2 years and $1.5 billion later, the facility was ready. Some 275,000 cubic yards of concrete had been poured to form the floor, enough to make 44 miles of 4-lane freeway. The assembly plant also required 85,000 tons of steel, or twice the amount needed to erect the Empire State Building. An innovative part of the new complex was a $370 million laboratory in which every part of the new airship would be tested before the real 777 ever flew. Boeing implemented a program called Working Together. Design teams from United, All Nippon, British Airways, and other airlines took up residence in the Everett plant, working alongside Boeing's personnel. In addition, consumers, mechanics, and pilots took part in the planning process from the beginning.
The important thing from the start was that they called in their customers, they called in the mechanics, they called in the flight attendants, they called in the pilots, and they said, let's make a plane that you want.
The first meeting, they turned to me and said, for flight guidance, do you want single queue or dual queue? Single queue is a sort of a top of a triangle shape, and the airplane flies into the top of the triangle. In double queue, you have 2 single needles. And I looked around and I thought, like Robert De Niro, are you talking to me? So I said, I'll have dual queue. And they wrote that down. I said, my God, that worked. Well, it was an amazing experience.
The people who work on airplanes, like the mechanics, cargo handlers, and flight attendants, were also canvassed for money-saving ideas.
And the cargo handlers said, you know, if you guys could move that little doodad there, we could get in another 10 feet of space. In another example, mechanics went in and said, look, we cannot use this tool of this size we need in this small compartment to remove this part. Either make the compartment bigger or move the part.
The most innovative and bold step Boeing took was to use a newly developed design system called CATIA. Computer-aided three-dimensional interactive applications. Using this new technology, Boeing designed and built a jetliner digitally, without drawing boards or mock-ups. This had never been done before.
We were going from the old 2D drafting board kind of technology to a totally new way of designing and building airplanes.
CATIA allowed designers to move parts around in the computer as if they were real. Using this program, engineers could work with a part before it was made.
When you look at something in 3D, it's the way you really look at an object. And the other big advantage that we have with CATIA is that it gives us the ability to look at different parts and how they fit together. And if they don't fit together, it identifies interferences.
Parts that interfere with each other are one of the biggest problems facing airplane manufacturers.
And we had to actually create an internal software that gave us the ability to look at thousands of parts. So when we created this software, it gave us the ability to fly through the airplane, identify those parts that had an interference, and to fix them.
By creating a virtual hand, designers made sure that mechanics had room to reach every part requiring maintenance.
The system allows you very high accuracy, up to 1,000th of an inch accurate. And it's really important with an airplane because any vibration or so forth is not good.
Of course, even the most brilliant design tool is useless without skilled designers. The 777 sent Boeing on a literal hiring spree, unsurpassed in airline history. Boeing assembled the largest computer design team in history, over 10,000 people, each with a workstation. The use of this revolutionary virtual technology allowed the 777 to be designed by teams around the world, as far away as Australia and Japan. By going online with each other, virtual meetings could take place, streamlining the design process. Using CATIA virtual reality to fine-tune construction led to significant savings.
A good example would be the storage bins. It used to take up to 17 shifts to install all of the storage bins, and with CATIA we do it in 2.
The 777's overhead baggage compartments open lower and are deeper than any others in the sky.
It has an automatic assist, so that when you start, watch what I'm doing now, when you start pushing on it, see how it takes over, and the bin automatically closes itself.
2.5 hours en route, America's Flight 78 is over the Atlantic.
It's huge, it's spacious, it's got high ceilings, and it gives you a feeling like you're flying in your own living room.
The 777's fuselage is a foot narrower than the 747, but it feels roomier. This effect was achieved through the use of curved ceilings and near vertical walls. Leg rests in business class let passengers stretch out, but seats fold all the way down in first class, letting passengers go completely horizontal. And every seat in every class has its own TV screen. In the higher classes, the entertainment systems are more complex.
Well, it's hidden. I had to find it first. And actually you just push, it pops out. The screen articulates up. And you bring it into view, and you actually can bend it back and forth a little bit so you can watch TV in the middle of the evening and not bother your neighbor. And currently the screen is showing where the aircraft actually is. It has a GPS system, which is actually kind of interesting. We get to follow the path of the plane.
Flight attendants learned that slamming toilet seats could upset passengers, either by jolting them from sleep or sounding like a gunshot.
This is our no sound dropping toilet seat. As I do this, power assist takes over, similar to the overhead bins.
Air circulation and ventilation is better in the 777 than in earlier models. In fact, the 777 has apparently solved one of air travel's smelly little secrets.
One of the problems that we run across a lot of times is people with maybe gas. I can't believe I'm doing it. It becomes a problem because you pressurize. I mean, this aircraft is pressurized, and your body pressurizes also, and it is a problem that we all endure.
A little bit easier to endure on this plane, though.
It is much better. It's a much kinder airplane to us. A giant leap for mankind.
For long hauls, the crew gets to be more comfortable than ever before. Behind the cockpit, pilots have a larger rest area, and in mid-cabin, so do the flight attendants.